my name is Josie, and I'm an SI leader for Math 115, and today I'm going to talk to you about applications of the central limit theorem. So for this problem, it tells us to assume that men's heights are normally distributed with a mean of 71.2 inches and a standard deviation of 4.6 inches. So let's go ahead and write that. Mu, which is our population mean, is equal to 71.2 inches. And our population standard deviation, which is sigma, is equal to 4.6 inches. But we want to find the probability that if 15 men are randomly selected, that they have a mean height between 70.3 and 75.2 inches. So the first thing what we want to do is draw our graph. Now it told us that this is normally distributed, so it's going to be a bell curve. And we know that our mu is always at the center of our curve. So the mean is equal to 71.2. And then we're going to look at what they asked us. The probability that 15 men have a mean height between 70.3 inches and 75.2 inches. So we know that 70.3 is going to be on this side of the mean. And we'll label that x bar, because it's a sample mean, is equal to 70.3 inches. And our other limit is 75.2 inches, and that's going to be on this side of mu. And we'll put x bar equals 75.2 inches. So the probability that we're looking for is between these two limits. So we'll go ahead and shade that in. Now, in order to find the probability, we're going to have to change our x bars into z-scores. And the formula to do that is z equals x bar minus mu over sigma, our standard deviation, over the square root of n, which is our sample size. So we'll go ahead and put that up here. N is equal to 15. So now we can go ahead and plug our numbers into our formula. So for the first limit, z is equal to, our first limit, our x bar is 70.3, and our mean, our mu, is 71.2 over our standard deviation, which is 4.6, over the square root of n, which is 15. And when we plug that into our calculator, we should get negative 0.758. And our next limit is 75.2. So let's plug that into the formula. Z equals 75.2 minus 71.2, our mu, over 4.6 over the square root of 15, our n. I'm going to go ahead and put parentheses around these too. When we calculate that, we should get 3.37. So now we're going to go ahead and write our probability statement. So the probability that x bar is greater than 70.3 and less than 75.2 is equal to the probability that our z is greater than negative 0.758 and less than 3.37. Now, since we have our probability in z-score form, we can use the normal CDF function on our calculator under second vars to get the probability. So that probability is equal to normal CDF, parentheses, we put our lower z-score, negative 0.758, comma, our upper z-score, 3.37. And when we calculate that, we should get the probability as 0.7754. So that's the probability that if 15 men were randomly selected, that they would have a mean height between 70.3 inches and 75.2 inches.